case study video on entitled Formation of Electrospinning Scaffold based on polyurethane containing grapes for wood dealing applications. The first vaccine will start this session.
So coming to the abstract, electrospinning is an emerging tool and a promising method to fabricate polymer nanofibers, which is aimed to for work this fabricate electrospinners, as I have said. Polyurethane mats reinforced with grapes and with wound dressings. Okay, it is confirmed that fabricated novel composite scaffolds having better physiochemical properties suitable for wound dressing application, which is suitable for everything. So coming to what is wound dressing. Wound dressing plays an important role in managing certain types of open wounds, like including traumatic, thermal or chronic wounds. Making wound dressings are biological, synthetic and biologic synthetic. The biological wound dressing, which is commonly used in clinics, are allow skin and pig skin, but they possess some drawbacks like limited surfaces, which is known as high antigenic, poor aggressiveness and risk of cross containment. So electrospinning will be carried by electrospinning.
So now we are coming to the electrospinning process. While coming to the electrospinning process, due to this electrospinning process, we are going to see the polyester and the grapes mix. So we are coming in a electrospinning method. We will be feeding a polyurethane as a furnace. So we are feeding that, and then we will be adding a grapes in it. We'll squeezing the grapes and will be pouring in it, and then that will be turned into a foil or a resin, like thermal. Due to voltage, it will be converted into nanofibers. So that nanofibers is the one which we are using to create the wound resisting, wound healing material. So we are going to make this, what is in this electrospinning process using voltage. So that's called as an electro. And the nano materials will be aligning up in a spinning process. So it's called as electrospinning. So while coming to in our equipment, we are going to deal with an ideal dressing must be provided in a moist environment. In the moist environment, the dressing should be done. So it allows the gases exchange, the wound interference, and the fight against the microorganisms. In our skins, there will be some microorganisms, and also in the body, there are more microorganisms. So while coming to the, also it removes the excludes and quick healing. So now, what are the materials we are going to use? Likewise, we are going to say about, as previously said, polyurethane. This is the major material which we are using. Polyurethane is a commonly used polymer, which will be feeding as a starting procedure in the foam. Material dressing in the form of foams. So membranes and films for wound healing applications. So this is the main application for wound healing applications. So in this we are adding the grape materials. So while coming to the grape materials, in this work, grape composite is driven using the additive called the grapes. So we are adding the grapes as an additive to the polyurethane. So fresh grapes extracted consistency from 70 to 80% of water, and many organic and inorganic components are there in the grapes. So while coming to in few major studies, we came to the report that the grapes are seeing an antioxidant, and grape is also an anti-cancer fruit, and then grape is an antimicrobial, and it is an anti-inflammation activity of the grapes, which reports phenolic constituents of grapes. So these are the pneumatic candidates.
So
Preparation.
So the preparation of solutions.
Okay, the preparation of solutions. P at 9% was prepared by dissolving 0.45 gram of polyurethane in 4.5 ml of DMF and stirring for 24 hours at room temperature. Finally, the solution of PU grape was prepared by mixing the PU and grape homogeneous solution in the ratio of 8:1 and stirring for maximum 2 hours. And the characteristics are: scanning electron microscopy test is made, contact angle measurement, thermogravity analysis, atomic force microscopy. And in the semi investigation, the difference between the polyurethane and the polyurethane grape is the fiber content from the polyurethane grape is less than the polyurethane. as we can see in the film analysis image. And in the FTIR analysis graph, we can see that the polyurethane key peaks polyurethane were NH and CH and CO groups. Compared to pure PU, there were no additional peaks observed in polyurethane grains. Due to the both peak was observed at NH peak. The strong increase in the intensity of 3328 cm per 1 in the x-axis group.
So contact angle measurements, the water contact angle for pristine PU was found to be like 100 plus or minus 1, indicating its hydrophobic nature. Hydrophobic nature in the sense absence of moisture. Absence of moisture. So while the PU grades nanofibers showed a contact angle of 86 plus or minus 2, indicating its hydrophilic nature. Hydrophilic in the sense absence of so in this graph we have been seeing along the x-axis there will be temperature, TJ graph, along the y-axis there will be weight percentage. So violet color will be represented as the PU grades and red color will be represented as PU. In this PU grades will be higher in nature comparative to PU because of thermal stability. So the surface roughness will be calculated over that. Then PU and PU grades. PU will be soft surface, rough surface, and PU grades will be smooth in surface because of its thermal and adding of lemon in the PU.
Finally,
so in conclusion, we saw about the as we saw starting, we saw abstract and we saw wound dressing. Electrospinning. What is electrospinning? So material used. We saw two types of material, which was a polyurethane and grapes. These two materials we saw. So preparation of solution. We saw how this solution is made so far, and we saw the SEM investigation, in which we found that the fiber diameter is less and thin in grapes, PU grapes, and compared to PU. Then we saw the contact angle measurement and TGA curve. So in which we found that PU has a smooth surface and the PU grades are the hard surface. Thank you.